Yeah, you guys are going to have a Sig Test tomorrow on Sig Test 21. So this is kind of what it looks like. Obviously, it's not going to be exactly the same as this since you guys will have different versions. I did want to help you guys with this, however, just so you guys can see exactly what I'm looking for so that when you guys take the Sig Test tomorrow, you know what it is that I'm looking for. So, essentially, it says to find the critical points. So, what graph is this? Read the directions. It says this is a graph of what? Good. This is a graph of f prime of x. This is the first derivative of f. So, keep that in mind when we're looking at our chart or when we're thinking in our minds about what we're looking at, that this is a graph of the first derivative. So, the first thing it says to do is we're going to label these things on the graph. It says to label them on the x-axis. I would actually rather have you label them on the graph where they occur. So wherever these things occur, I want you guys to label them. So we're looking for the maximums of f of x, which is the original function. We're looking for the minimums of f of x. And we're looking for the points of inflection of f of x. So maximums and minimums we're looking for similar places on the graph, but obviously some of them will be maximums and some of them will be minimums. So do me a favor. How do we know when we will have a maximum from judging by this graph? How do we know when there will be a maximum on f of x? I hear when it's going from increasing to decreasing. Is that right? Yes. So from increasing to decreasing, what does that look like here? To give me some x values that I'm looking at.
0.
I hear 0. From increasing to decreasing, we say this is a maximum. So I should label it right here as m. Is that right? Don't copy me yet. I'm asking a question. Is that right? Thank you. X for maximum. Is that right?
Yes.
Most people say yes. I see a few people that are naysayers. Any naysayers want to speak up?
Oh, wait. This is f prime of x. Oh.
This is f prime of x. So you guys just found a maximum on f prime of x. Congratulations. Nobody cares about that. What does the directions say? The directions don't say find the maximums of f prime of x. The directions say find the maximums of what? F of x. How does the first derivative help us find the maximums on the original function? Good. When it goes from positive to negative, it's a maximum. So do you remember that we will have maximums and minimums wherever there's a horizontal tangent line on the original function? Do me a favor. Look at horizontal tangent on f of x. What's right below that? What am I looking for on the first derivative? Zeros. I'm looking for zeros of the first derivative. So this is not where I have a maximum. My critical values are here, here, and here. So I agree with you that that's a critical value, but it actually is not a maximum. So I need to put a maximum where it goes from increasing to decreasing on the original function, which is where it goes from positive to negative on the derivative. So which of these 3 points goes from positive to negative? Negative 1, right? It's positive and then it's negative, which means that the original function is increasing and then decreasing. So this is where I would put an x. That is a maximum on the original function. Again, because my first derivative is going from positive to negative and I have a horizontal tangent line in between, that means there's a turning point right there, and it's a maximum because it's going from increasing to decreasing. The original function is going from increasing to decreasing. Okay, with the same logic, which of these 2 points left over is a minimum?
1.
Good, this is a minimum. Who can tell me why? Justify your answer.
Negative to positive.
Good. The first derivative is going from negative to positive, which means my original function is going from decreasing to increasing. So this is a minimum, so I'm going to put an n. What about this point in the middle? What's this point in the middle? It is a point of inflection, but it's also a 0. Notice that it's still a 0. Which means if it's a 0 on the first derivative, it's a horizontal tangent on the original function. But it's not a horizontal tangent that gives a maximum or minimum. Who can tell me why I know that for sure this is not a maximum or a minimum? Good, it's not changing sign. Notice that it's negative on the left-hand side, and it's negative on the right-hand side. That means my original function was decreasing and decreasing. So it didn't actually change from increasing to decreasing or vice versa. So this is not a maximum or a minimum. It's just a flat part of the original function. All right, so keep that in mind. So I actually don't need to put anything there for that one. All right, so I finished this one and I finished this one. Now let's look for all of the points of inflection from f of x. Do me a favor and look over here. For f of x, do you guys see where it says possible point of inflection? Okay, look right below that for the first derivative. What am I looking for? I'm looking for a horizontal tangent line, so I'm looking for a turning point. Okay, do you guys see turning points? What x values do you see turning points at?
Negative 0.5.
Yeah, like negative 3/4 or negative 0.5. Okay, so this is a turning point, so that's a point of inflection on the original function. Positive 0.5 or positive 3/4, that's a point of inflection. There's one more.
0.
Good, at 0, this is also a point of inflection. So all turning points on my first derivative are points of inflection on my original function. And again, I know that because notice that the first derivative is decreasing and then increasing, which means that my original function is concave down and then concave up. So it changes there. And then it goes from concave up to concave down. And then it goes from concave down to concave up. So I have 3 places where my original function will change concavity or change its inflection. So we're done with that one. All right, last 2 questions. The first question wants to know on what domain is f of x concave up? So look over there, concave up. Do you see concave up on the original function? Look right below that. What am I looking for? Increasing. What x values is my function increasing for? Increasing? Where is this function? Because remember, if I'm looking for concave up, I'm looking for where the first derivative is increasing. Where is this function increasing?
Negative 0.5 to 0.
Good.
0.5 to whatever.
Good. So we'll write negative 0.5 to 0 union positive 0.5 to, let's not say to infinity, let's just say to like, well, for right now you can say infinity. You'll see on tomorrow's Sig Test it doesn't go to infinity. But it's very clear what x value it stops at tomorrow. All right, so that's where it's concave up on those 2 yellow highlighted intervals that I just drew. You guys don't need to highlight them tomorrow. As long as you write the domain over here, that's what I'll be grading. And then last but not least, we're trying to figure out where f of x is decreasing. So if I look over here for f of x, and I find decreasing on that very top row, what's right below it? What am I looking for on f prime of x? I'm looking for where f prime of x is negative. So who can tell me where this function here is negative?
Negative 1 to 0.
Good.
Can you just write negative 1 to 1?
Good question. Technically, at 0, it's not decreasing or increasing. It's a flat part of the graph, right? Personally, I don't really care. If you guys skip over that, that's fine with me. So if you just want to write negative 1 to 1, that's fine. Or if you want to actually break it up around 0, that's fine as well. I think technically it's more accurate if you break it up around 0. But I would give both as correct answers tomorrow. Alright, so is it clear what you guys are being asked to do tomorrow?
Yes.
Beautiful. So again, the graph will not look exactly like this. The questions will maybe not be exactly like this. But this is essentially what you are being asked to do on the test tomorrow, on the Sig Test.
Can we use our little paper?
Yeah, you can use your paper because that's going to be on the wall up there.